connection, we are now able to see all of our files within the Bitbucket repository. Then we selected the appropriate Docker file that we actually want to make use of. And then we went ahead to, create the name tag. And then we said that the name tag must be equals to, must be the same thing as the name of your repo, be it on Azure, be it on AWS, be it on Docker Hub. But for simplicity's sake, we made use of what? Docker Hub. So this is the name of my Docker Hub repo. And of course, we created some variables, that comes with Teamcity natively. So that by the time we build this particular image, right, there's a build.counter that's going to be attached. And that build.counter is a variable that came with Teamcity. So that by the time you start building, right, the counter is going to continue to rise. So if you have built 10 times, what is going to be here is just 10. And this is just to enable you to sort of distinguish and have a history of all the Docker images that you've built in the time past. So that is what this is all about. Then, of course, you can leave the other defaults. Then the next bit is the Docker push. We are saying that after we are finished building, right, we need to push to a particular repository somewhere. So last week, we talked about how to be able to connect to the repository, right? And then the Docker push, it's just the same name tag, and then you select the push, and then it's going to push to your repository. All right. So let us just run it and see if this is still working. So to be able to run this, you can run it in different ways. To be able to sort of build all of this, you can also click on run here, right? And then there's an agent that will now handle the building. So again, we may mention last week that the server itself, that's the Teamcity server, is just for administration only. And it's just for, specifying all of the build configurations, your VCS configuration, and so on and so forth. But the main guy that is responsible for the actual building is the build agent, which you can see here, is the build agents. So these are the different agents that we installed last week. So that by the time I run a build, right, the agent that is compatible to be able to run that Docker build will pick it up, and then it will run it automatically. How do we know this? Let us go back and check the myGolang build, right? And edit the configuration once more. Then by the time you click on agents requirements, we have already specified here that the only agents, even if I have 200 agents, we have already specified here that any agent that has Docker server version, meaning if you can run Docker version and you are able to get the version of Docker running on that agent, then you can make use of that agent to build it. That is what this condition does. Meaning if Docker server version exists, right, then assign it to be able to run this build. And that is what you can see here. Do you understand? Sandbox-1. That is what you can see here. Okay. So that was what we did last week, pretty much. Okay. So we have run the project. So let us see if it was successful. How do you see if it's successful? Just go back home, right? And click on it. Click on your build name. So this one was the one that we just ran, right? Of course, this is the name of the agent. It ran for 6 seconds and it was successful. So if you click here and check for the build log, you can, be able to see everything that happened. You can see within the build log, you can see the step 1 and the step 2. So you can also expand this to just sort of have an idea of what really happened. You can see it did all of the go mode, copied all of the files we need. It even ran the tests as well. That's also to tell you that our unit test has been embedded in our Docker file. So it ran all of the tests and it exited with code 0. So code 0 means that everything is fine, everything was successful, and then it exited and it moved to the next step over here. So this is the next step. Just it's just for us to be able to build and what have you. So, and if we should go back, so this is what version now. Let's go back to the overview. So this is version 7. It has pushed to Docker Hub. So it means if we should go to our Docker Hub over here and we refresh this, we should see 7 here. Can you see? We should see 7 over here. So, and it was pushed how many minutes ago? 4 minutes ago. So it means our pipeline is fine. Good. Now, this was what we created last week that helped us to build a Docker image. Now, what now happens if an organization is not making use of Docker, right? They are just building the applications and they expect you to be able to deploy that particular application on an EC2 instance or a VM somewhere on your infrastructure, or just on maybe a VM on Azure, or a droplet somewhere on what's the name of the other cloud itself. So what happens if you need to do that? You are not going to say that because I know how to build applications, to run within a container, then it means they must have to also do likewise. No. So whatever it is that they want to do, right, you should be able to also replicate it on Teamcity. Whatever it is that can be done manually can also be done on Teamcity. Whatever it is that can be done manually can be done on Teamcity. So let us go ahead and build this same application, but we're not going to run it, within a Docker container itself. So let's check our repository. Okay, let me switch the repository to what we have. So this was the project that we built last week, and we started with the develop branch. So under the develop branch, we have Dockerfile, the Dockerfile.lite and all. What if we don't want to make use of Docker at all? What do we need to do? We just want to build it natively. The same way we've been building here. Remember this part where let me remove this. Remember here where if we need to just build this Golang application, we just want our Go build. So let's say we want to output it to, let's say, web form. And what do we want to build? We want to build from this webform.go. So this is just the code base. We want to build this code base and then output it to webform.go. It's very simple. You just need to run this command and then you're going to see the webform.go. So this is the artifact that you can now use to, that can now make use of to deploy on your target environment. Do you understand? Now, we need to do, so this is just the manual way. We now need to replicate this on Teamcity. What do we need to do? First and foremost, we need to install what? The agent, because the manual way we are doing this, right? The manual way that we made use of in running this Go build, we need to inform an agent to help us run the same thing. So the first thing we have to do is to install the agents. How do we install the agents? It's very easy. Remember the command that we ran last week. We ran this command where we mapped the var run docker.sock. So this would help you to be able to build Docker related builds. Hello?
Yes, we can hear you now.
Yeah,
Okay.
we can hear you, sir.
Okay, yeah, cool. So this will help you to, install an agent that would build all Docker related tasks, right? And you are doing that and then making reference of the Teamcity agent, JetBrains. So JetBrains is the name of the organization that actually created Teamcity. So they've given us a free image, to serve as the agent. So, but this agent itself is the only agent that we can make use of to only build our Docker images because of this var run sock that we have. Now, what if we need another agent, right, to build our Golang project? What do we need to do? It's still the same thing, but instead of attaching the -v flag, right, to be able to build your Docker images, here, we're not actually making use of that. The only thing that you just need to do is, first and foremost, you need to build an image. You need to build an image from a minimal Teamcity agent. So Teamcity, is kind enough to tell us that, so look, whatever it is that you want to do, right, you can start building from a very minimal agent that we have created for you. Because Teamcity does not have, the capacity in their own way to provide us all of the images to build the different stack that we have today. For example, now, Teamcity does not have a specialized image to build Java. They don't have a specialized image to build Golang. They don't have a specialized image to build .NET projects, Node Express and all, because they don't have that time. The best that they've given us is that I've given you an image to run the Teamcity server. I've given you an image to run a Docker build, right? Thirdly, I have given you another image that you can build upon to run any stack that you want to make use of. And that is what this Teamcity minimal agent does. So they've given all this agent to say that you can make use of this, build upon this particular image, and install anything that you want to install, on the agents to be able to run your builds. For example, let's say we want to run an Android build right now. Teamcity does not have they don't have like an off-the-shelf image that can do that can run Android-related applications. They don't have that. But what they have is that they've given us like a foundational minimal agent. By the time you have that, then create your build steps to now install whatever it is that you want to install. And that is what we have done here. I don't need to go through this because this is already, on Golang's documentation. So you can see we have talked about the from. We're making use of the base image here that Teamcity had given to us. Then the advisor that we should set some environmental variables and all. The Go version that I want to install inside this inside the container is what version 1.21.3, and this is the latest. Then of course you need to run some updates, you need to install some other things and what have you. So I have done this already, right? I have built this, built this image, and I named it Teamcity Golang column latest. And this is what we have here. So if I do my Docker image ls, you can see it here. So I built it this morning just for the purpose of this class. So this is it here, and it uses the latest tag. right? So this is what we have here. So what do I need to do? I need to, create the same volume to be able to store all of the configuration data and what have you. So I created that and, pointed to the server the same way we did last week. So the server is running on port 9999. So if I should do Docker PS, you can see this was brought up last week, 6 days ago, and the external port is what 9999. So this was what I did here. So I ran it. So after running this, it means we now have a Golang Teamcity agent, right? Which is what you can see as sandbox 1. Am I making sense, guys?
Yes.
Okay. Does anybody have any question? Or are you guys confused? Is there any confusion in the house?
Yes, so during that agent part.
Okay. Go ahead, Emmanuel.
Emmanuel, go ahead.
I mean, I'm confused based on the agent part when you're trying to connect the agent, because that's where my problem lies. Because I don't know, if I run it, if I copy the agent and I run it, it will always tell me about space issue, stuff like that. So I can't do beyond that. So that's where our problem lies.
But I told you what to do now. I told you what to do. If it's complaining about space issue, of course you need to free up space. For example, now when I did my my Docker image ls, can you see the size of the Teamcity agent? 2.28 gig. But you have 1 point something gig free. How do you expect it to work? Emmanuel?
The point is that I actually have to increase the RAM size and the CPU size, but
No RAM. This is storage, Emmanuel. This is storage. This has nothing to do with RAM and CPU. This is storage. You can see 2.28 gigabytes of storage.
So how can I solve that, please? Because I don't know how to go about it.
I told you what to do already now. You are running from an EC2 from AWS. Just attach a volume now. Just attach an EBS volume. That's all. I told you this already on Discord.
Yes, sir.
Okay, let's move on. Okay, we have any other question? Can we move on?
Yes, sir, we can move on.
Yes.
Okay, all right. So now let us now go ahead to create the build steps to be able to build this Golang application. Remember, we are not creating build steps for Docker to run as a container right now, but we actually want to create it natively, the same way we are running here, the same way we are doing the Go build manually. So what do we need to do? Go back to our project. Since it's going to be a Golang project, we can still create it under the Go project over here, right? You can still create it over here. So what do we need to do? So go under the projects and let me see. Go to administration, click on the Go projects, and let us create a build configuration. Did you get what I did? So from home, if you need to create a new build project under the existing Go projects, right? You have to go to administration, then under projects over here, click on this Go project. If you have, let's say you have a .NET project, you can just create a .NET project over here, right? And just create it. Then from here, you can now start creating your build configurations. But because we are not making use of .NET projects here, we are making use of Go. So we'll go and select that of Go. So I'm not going to make use of .NET. I'll make use of Go projects. Then scroll down and create build configuration. So, what name do we want to give this? Let's give it Golang native because we want to build it natively. Right? Click on create. Then it's telling us that we should attach existing VCS root or we should create a new VCS root. So we don't need to create any VCS root because it's still the same project as we have for that Docker project that we built last week. So what we are going to select here is to select an existing VCS root. So once you click on this, right, you can see all of the VCS roots. So we're going to select the Go project VCS, and we don't need to enter username or password or to check if you can connect to the repository, what have you, because this has already been verified last week. We just need to select it and we're good to go. So now let us now go ahead and configure the build step manually. So what do we need to do? Click on configure build steps manually. Then because Teamcity does not have sort of like a specialized Golang plugin over here, right? You are not going to be able to see any of these Golang plugins as you have here. For example, let's say we want to build maybe like for Python. I'm going to select Python here. If I want to build for .NET, I can select any of the .NET runner here that are not deprecated. If I need to build maybe what else? Maybe C#, I can select this. Or .NET, of course, I can select it. But because I need to build Go, and Go is not here. But I know that within my agents, the Golang agents that we installed here, because I know that Golang is already installed inside this. How do I know? Let us exec, docker exec, interactive mode, copy the Docker ID, space, and bash. So you are inside these agents right now. So how do we know if Docker would run? We don't need to do go version. So can you see the version of Docker running inside this container that is meant to build the Docker image? So it means that Docker is installed inside this and we are good to go. Do you understand? Now, it means inside, so let me exit. It means inside this particular agent, right? I can just make use of the command line because, of course, this is just a command line to, that I can actually make use of to, build the Docker projects and what have you. Let me exec one more time and do as if I want to build an image. So Docker build. Can you see? It is telling me that go mode, whatever, not found. That also tell me that this terminal, the bash terminal inside this image is ready to build any Go projects. So because of that, I don't need an extra runner. I don't need a Go runner. What I just need to do is I just need a command line. That's all. Because with this command line, Teamcity is going to run inside this image. It's going to run inside the image itself. Do you understand? So let's make use of the command line. What will be the step name? Usually we do a what? Build, let's say build Golang, right? Then the working directory Now, this is very, very important in Teamcity or even Jenkins or whatever it is that I'm making use of. There's what we call a working directory. Now, this working directory, what Teamcity does or what Jenkins does is that it checks out the VCS itself. It checks out all of this code. What does checkout means? It just does a duplicate of what we have here and saves it inside its own container. Again, let me repeat myself. Before these agents start building the Golang application itself, the first thing it does is that it checks out the VCS route that you have specified. Of course, the VCS route is just your project as you have it here. So it checks this out. And checking out means that it copies all of these files onto itself and then builds the application after checking it out. So that is what this place stands for, working directory. So if you just leave it by default, right, the agent itself is going to create its own working directory, which we're going to see, very soon. Then, of course, run is constant strict. You can just leave all of the default like this. Then what do we now want to do here? Remember this command that we ran here. We did what? Go build -o web form. If I should still do this, if I should still type this, go build the output web form without specifying the web form.go. Go is intelligent enough to know the file that ends with .go, because that is the only file that ends with .go. This also ends with .go, but of course, it has a test within it. So Golang would pick this because it is not a unit testing script, but this defines the main code base, like the main application itself. So if I run this, you can see it will still build the entire package or the entire application for you, even without specifying. It will just pick the name of the application itself and then name it as a build name. So this same thing is what we also need to do here as well. So what do we need that agent to do? We need to go build -o web form. That's all. That's all. Then we'll save it. So this is the first build step. Now, once this has been done, right, we now need to add another build step. So what will this build step do? Let's still create a command line. Now, this build step, right, best practice is saying that within your build, there's what we call an artifact. An artifact is the end product of your build. And inside the artifact, you have your what? Your configuration files, you have your build files, you have some other information pertaining to the build that you just created. So best practice is saying that in all your builds, right, you can also export the build version inside your final artifacts. Now, this is what I mean here. This is your final artifact, right? You have your build. So this build is what you have to go and deploy on your server. So this build is what you have to go and deploy on your server. We are good with this. Best practice is also saying that within this, your artifact folder itself, you can have some other configuration files. You can have some instruction files that would sort of provide a context onto how to be able to run this build. You can have like different files accompanying this build folder that you have. So inside here, what I usually do is to also echo the version of the entire artifact, so that by the time this build has finished, you will see a file called build version. Inside that file, you will now see the the version of this particular build itself. Maybe it can be version, maybe 1.2.5. So that by the time you now want to hand this over to maybe the sysadmin that is going to deploy this, it can always make reference to, this version number that is here. And the reason why we usually used to do that is that, for example, now, if there's a change release, in most organizations, there's a document that is usually called the change release document. The change release document contains what you need management to approve before it goes to production. So let's say the QA has already certified that this particular build is good. The QA is now going to create a document called change management. She will write that I have tested version 1.2.5 and below are my tests results and everything passed. So she raises this to management. Maybe the head of department approves. Maybe the head of QA approves. Maybe the CTO approves. The CIO approves. By the time all of these guys have approved, right, the sysadmin guy is going to get a mail informing him that we have all approved, though. Please deploy only version 1.2.5 to production. Now, this guy does not need to start asking the QA, please, where is the build for what you've tested? What he does need to do is also check his CI/CD pipeline and check inside the build folder to see if this version 1.2.5 corresponds to what is inside the change management approval. If what has been approved is maybe 1.2.5 maybe .57, and what is inside here is maybe 1.2.5.52. The sysadmin representative, of course, would see the discrepancy, and it will be very foolish for him to be able to, deploy what was not approved to production. So that is why usually for me, best practice is, I know there are so many ways where I can, make use of or check the version number of what has actually been approved. There are so many ways, but best practice is saying that let me even put it inside the build folder itself, so that as it's building, it is echoing the version number of what has been built. And at least I can compare with other sources and we'll be good to go. So that is why here I'm saying that within my build, right, I want to make a directory first and foremost. So we all know the Linux command to make directory, mkdir. So what is the name of the directory I want to make? You can call it anything, but I usually used to call my own build _dir. So after this, right, I am now informing Teamcity that, Mr. Teamcity, whatever version number that you want to give to me, because at the end of running this, you are going to give me a version number, of course, within Teamcity. And this is like the version number that Teamcity had been giving us. Can you see 5.0.7 and all? I'll now tell Teamcity that, Mr. Teamcity, echo the version or echo a variable called version. This can be anything. I can call it Dapo version. I can call it Emmanuel's version. I can call it anything, but let us keep it simple. Echo version. We all know what echo does, right? It just writes to a particular file. So that's just the same thing that we're trying to do here, right? So we are saying echo version is equals to how do we now specify the build number that Teamcity appends to all of our image automatically? The keyword is anything that Teamcity handles must always go within 2 percentage sign. this way. Do you understand? So let us do that. So you're going to append the first percentage, and you can see all of the parameters. You can see all of the parameters within Teamcity. So the one that we actually want to make use of is what? Build.number. So this build.number is equals to what we have here, right? So now, what do we now need to do? We need to write it to a file. And what is the name of the file? Remember that we created a directory, build_directory. We now say that within this same present working directory that you have, which is dots, go into the build_dir that we created, right? And then create a file called build_version. That's all. So it's going to make use of the build number for this particular project itself, and then it will write it to a file called build_version. If this file does not exist, right, Linux is going to create it automatically. We all know that. So this is saying that within this same present working directory, go into this folder and create this file for me. Now, once that is done, you know that when we ran go build-o web form, it created a web form here. What we are just trying to do is that this is what we are trying to do. mkdir build_dir here, right? So this is a new build folder that we've done. We have now said that within this build guide that you have here, like create a file called build_version. And at the end of the day, what is going to be in this particular file will just be, let's say, maybe 2.9. No, that's going to be version is equals to 2.9.0. This is just what we want to do. So all of these manual processes that I've done here is what this script will do. Do you understand? Right. Now, once that is done, to make everything to be neat, right, I can now move this artifact because, interestingly, this is just the only thing I need. This is just the only build artifact that I need. I'll now move it inside the build dir I will have here. Do you understand? I'll now move it to the build dir that we have here. And then if I now need to export it out, it's just this build_dir that I'm going to export out. Do you understand? So now, how do we now move it? It's the same command, move web form. Where am I moving it to? I'm moving it to a folder in this present working directory, which symbolizes dots. What is the name of the folder? This. That's all. That is what I need to do. Okay, so I just need to wrap this around quotation this way, and we're good to go. So what step name can we give it? Let's name it maybe Golang version and package, sort of. So we save it. Are you guys with me?
Yes.
Hello?
Yes.
Yes.
Yeah.
Okay, now, before we run this, let's now see if that agent that we installed is compatible to run this particular build. Where do we need to go to? You just click on agent requirements here, right? And right now, it is telling us that for now, you have two agents that can build this, that can build that Golang application itself. So let's try it and see. Let's try it and see. Let us run it and see if this is going to work for us. You can see it failed. So why did it fail? Let us check. let us check the build log and see why it failed. Can you see? It is telling us that Go not found. But we have Go installed here. Go is installed here. Go is installed in, in one of the agents that we have. But remember that when we run this here, let me edit this configuration. When we ran this and we went to the agent requirements, right? This guy is attaching itself as if it can also run Go. That's the second Docker agent that we have. But it cannot run Go. Meanwhile, the guy that can run Go is not allowing it to run. So what do we need to do? We now need to add what we call a requirement, the same way we did last week. So click on add requirements. And Teamcity has different requirements it uses to be able to distinguish what all of the agents can do. For example, if you have 200 agents, Teamcity is intelligent enough to know that, okay, this agent can run this agent cannot run this agent and this agent can run this other agent can run this, but this one, like, it knows how to be able to distinguish all of those things. And those things are called environmental variables. So by the time you start typing env, you will see all of the variables. So now let's see the one that our image alone is there, because you can see that this is showing what two agents, sandbox one, and all. But the one that we actually want to make use of is this Go root, or we can make use of this Go part or Go version. You can see that right now, Teamcity has been intelligent enough to be able to weed out the guys that are just forming as if they can do anything here, right? So the only one that can actually run the application is this sandbox. So we'll select this, right? So we'll now say that if environmental Go root exists, meaning if there is an environment called Go root, right, in that particular agent, then it means it is sufficient enough to be able to run the job. So that is what this condition does, exist. If it exists, then we should go. Now, once you save this, right, the odd guys will move to the right, while the main guys will still remain here. Let's try this. So once you save this, can you see what has happened? It is telling us that incompatible agents, this guy here does not meet all of the requirements. But this is the only one that can run Go because it has Go installed. So we are good. So let us run it one more time and see what will happen. So let's go back to our project. So this time it should pass. If it doesn't pass, then it means something else has happened. So let's see, Golang native. So you can see what has happened here. It is successful and we are good to go. So let us now check the build log to see what really happened. So check the build log and let's see. So you can see the first step that we created, right? It did something here. You can see checkout. So checkout means that it copied all of the code and all of the files that we have here. It copied it onto itself. That is what this checkout does. It now went ahead to now run all of the build steps. So you can see where it checked it out to. It checked it out here, and then it went to the next step and did some other things. So because we are curious, we need to see what really happened, right? You can actually exec into this guy here and check what has happened. Or from your agent over here, this was the agent that we used. You can open the terminal from your browser. So let's go in there. Right, and let us bash it so that it would good. So going back to our project, let us see what it did. Hello?
We can't see your screen though.
Yeah.
See your
Oh,
screen.
okay. Okay, sorry. I don't know, maybe it was my network. Okay, can you see my screen now?
Yeah, we can
Yes.
see.
Okay. All right. So so we need to know what happened. We need to know all of the builds, because this thing is very, very important. Don't just assume that this thing has built and I am good to go. You need to know all of the steps. Like, you need to be very, very curious. You need to be very, very inquisitive. How did this thing even build? So that by the time you start having issues, you would immediately know where to go and resolve that particular issue. Very, very important. So that's what we want to do now, right? So this was our Golang native that we built, right? It was successful. We are good. We are not arguing. Then we click inside and check the build log. Let us read the line one after the other. Collecting changes, updating tools. You can see it's using the VCS information, and then it created a what? A checkout directory. So this checkout directory was what we defined here. This checkout directory, let me edit our configuration once more. Go back to the build steps, edit this. So this working directory here that I can see here is this checkout directory. So let us copy it. We are inside the agent itself. So let us cd into that particular part. Paste. ls. Can you see it? Can you see that everything that we have here was checked out from here? You can see that there's no difference between what we have here and what this guy copied to his own directory. So it will first copy it to itself. So this is the agent. It will first copy it to itself, right? And what was the next step? We told it to what? Build that image. I'm sorry, to build the app itself. So let us see if it's here. So it is not here because our command is saying that after building, it should move it to what? Build_dir. So the second step is create build_dir and then move the web form and then the build_version file to it. So let us go into the build_dir here and do an ls. Can you see the two things that we have here? The web form, which is still the same thing as what we did here, the web form here, right? And the build version. So let us cut it and see. Sorry. So let us cut the build version. Can you see? Can you see the version? Version 2. So is this not the same thing as the version 2 that is here? Do you understand? So let's make some modifications just for you to be able to see some other things. So so instead of just version is equals to, you can just put maybe like v, maybe version or something, or version number sort of. So let's save it one more time. And let us run it again. So let us see if it runs successfully. So Golang native. So it ran. So if we should go back here and do another cut, can you see what we have here? Version is equal to version number 3. So whatever it is that you specify within your build step is what is going to be replicated here within your Golang agent. Do you understand? Now, moving on. These are actually built, right? We are good. I don't want to always log on to the agents, as you can see here. I don't want to always log on to the agent to go and get my web form because, interestingly, really, this is just the only thing I need to be able to build. right? I don't want to always log on to the image. Then from the image, I'll now copy it out and start doing and all that. You can make use of the artifact feature so that by the time you specify your artifacts within a particular build, you can actually download it, which is what this icon is talking about. It's telling us that this is actually built, but you have not defined any artifacts in this build, because I want to be able to click here and then download the artifact and do whatever it is I want to do. So what do we need to do? We need to edit the configuration. And then under the general settings here, you see what we call artifact paths here. So this is where you actually specify how you want the artifacts to be. Now, what does this mean? Saying that you can use some Teamcity specifications here to specify how you want to be able to download the artifact. Now, what does that mean? It means we are telling Teamcity that once this has been done, by the time this has finished, right? By the time the build has finished, we need to be able to download only this build_dir, or we want to convert it to zip, to a zip folder, and then download it from our browser. How do we specify that? It's very simple. For you to be able to specify that, you say that we want to add some files by specifying plus column this way, right? We want to add some files. What files do we want to add? We want to add the build_dir folder in this present working directory. So the present working directory is specified by typing dots. Dots is this present working directory. Then within the present working directory, the file that I want to copy is only build_dir. That's all. Do you understand? That's all. So plus column is saying that I want to add. What do you want to add? Build_dir in this present working directory. That is what this dot is doing. If you need to copy every other thing aside from build_dir, we just use a negative sign this way. So this is going to copy everything here aside from this folder. It will copy it out so that you can be able to download it from your browser. But since we only want to move this out, since we only want to copy, because really the sysadmin guy does not need all of this. It doesn't need the Docker file. What does it want to do with Docker file? The image has already been built. The only thing it does need is just what? The image, which has already been pushed to Docker Hub, or the artifact itself, which is this web form. So that is what we're specifying here. So let me just change it back to plus. So after I've done this, I will now say that it should convert it to a zip folder. So how do we do that? You need to specify the targets this way. So the target can be any name. So let's name it maybe like Golang app artifact.zip. That's all. So we are saying that we are only interested, we're only interested with copying only the build_dir, right, out from the agent directory onto the browser and name it Golang app artifact.zip. Once you have done this, you just save it. So let us run it one more time and see the difference. So we'll run it here and then go to our projects and see. Can you see right now that the Golang, so this is our Golang native. You can see by the time I click here, I can now download this to my browser. So I can now download this. And here, oops, let me extract here. And you can see the web form, and you can also see the build version. So let me open with, you can see version number 4. So that is how to make use of the artifact parts here. Right. So question now is, based on what we have downloaded here, based on that web form, how do we run it? Remember that if we need to run it on our machine locally, what we just need to do is to go to this web form here, open in reveal in file folder, and okay, and rename it to .exe. Right? So this is expected to expose port 8080, and it should bring out the color, what have you. So if I should double click this, right? So it's currently listening, and if I should go to our browser, because it's running on my machine, and type localhost 8080, right? And then append whatever it is that I want to append, the application is running fine. So the same thing is applicable to, now the thing is that once you build with a Linux agent, you can only run this web form on Linux. But if you should build with a Windows agent, you can only run this on Windows. This is very, very important. Now, because you build this on Linux, we can only run this web form on Linux. So how do we do that? I think I already have one here. Let me exit out of the container. This is the web form. You just need to, call it this way. And it's already listening. So how do we call this? We just call it by what? The IP address of this server and the port 8080. So which is my daas.local, and then port 8080. You can see it's still the same thing. So I am running on Linux. Am I making sense, guys? Am I making sense?
Yes.
Okay. All right. So this is just running natively without running within a Docker container. So this is just like the opposite of what we did last week. So this is running it natively. So this is what the sysadmin, remember this illustration here. So this is what the sysadmin is checking the version and is deploying this artifact. So this artifact that I can see here is what we have here, web form that's web form itself. And we are running this. Excuse me. And we're running this, and it's running perfectly on production. Do you understand? And we are good to go. So this is deploying natively. You can see that the deployment I'm doing here, I'm not deploying from a Docker container. I'm just deploying natively. So of course, this is just for test, but if it's production, you have to install this as a service by using the systemctl utility to be able to install this as a service. But of course, just for test, this is how we are going to run it natively on production. All right, so let me just stop this. So moving on, let's just quickly talk about Octopus Deploy. Now, Octopus Deploy is a continuous deployment tool. In fact, a very powerful tool for deploying artifacts on target environments. You can see that here, what I just did was to deploy this manually, but Octopus Deploy will do something for you. It's going to ensure that once this is done, once it has built, it's going to hand over this artifact. Instead of downloading it manually, it's going to hand over this artifact to a deploy guy or a deploy tool that can now deploy this on the environment and then run it automatically. That is what Octopus Deploy does. From the word deploy, his own is let me just deploy. So it is a continuous deployment tool, a very powerful one for that. Like, it is widely used. In fact, it's now gaining more grounds than even Jenkins. It's widely used and it's very, very easy to set up. So that is what the guy is going to make use of to, deploy your artifacts to any target environment. That now brings me to understanding what is the difference between continuous deployment and continuous delivery. This is a very, sacred question that you should be able to answer anytime you are out. People will just say continuous integration, continuous deployment, continuous integration, continuous delivery. But what is the difference between that delivery and deployment? The answer is very simple. Delivery is deployment to your development environment. Delivery is deployment to just a target environment. It could be your QA, your develop environment. It could be your any other environment apart from production. Very, very important. That is delivery, because you are delivering that deployment to a particular target environment. Now, this is what I mean here. This is your CI, right? CI goes to CD. CD picks it up and just deploys to an environment only. So this process is called what? Delivery. Very important. You can see that it stops here. It's not going further. Why deployment is CI goes to CD. CD deploys to, the right word is CD releases to a target environment, maybe QA dev, and then it releases it finally to production. So there's no break. So this is like QA or dev, and this is production. So this complete cycle is what? Deployment. Why this is what? Delivery. Am I making sense, guys?
Yes.
Good.
Yes. Yes.
So once you are able to differentiate between these two, then you are good. Not everybody knows this. Everybody will just say, okay, in my CI/CD, what is CI/CD? What are you telling me? What are you doing? In my continuous delivery pipeline, I deploy to production. Like, are you really making sense? Do you understand? So it is good that whenever you are in a public gathering and maybe you've been tasked to talk about best practices when it comes to CI/CD, you need to use the right terms, because where you are, right, they are also experts. They are read books. I was able to read books to be able to understand the difference. I don't just watch YouTube videos to just do Jenkins. Okay, it has deployed. I'm good. You need to read books to understand what all of this is. Do you understand? So that is very, very essential. So Octopus Deploy does both delivery and what? Deployment. So under the Octopus Deploy architecture itself, it's quite similar to what we have for Teamcity. Remember that for Teamcity, we have what? The Teamcity server and what? The build server. The same thing for Octopus Deploy as well. Octopus Deploy, we have what? The Octopus Deploy server, this guy here, and the Octopus Deploy tentacle. T-E-N-T-A-C-L-E, tentacle. Tentacle is those things those stuff, those I don't even know the word to use. Those things that you usually see on octopus. That's why it's called a tentacle. So this is octopus animal. So
like the 7 legs or something.
Exactly, like the leg, but not really the leg because it's not working really. So these things, they're the tentacle. So what you can see, so the head here is more like the server. Let me open it for you very well to see. So the head here is just like the server, while these things that you can see here is called the tentacle. And these are like the agents that will always communicate with the server to deploy. It's as simple as that. So that was where Octopus Deploy, that was where they got their name from. So you can see their logo. It looks like an octopus as well. Do you understand? So the Octopus Deploy, right, has what? The Octopus server and the deploy tentacle. It's as simple as that. And the tentacle is the agent. It's just an agent that is responsible for actual deployment. Now, there are two types of tentacles. There is the listening tentacle and there's the polling tentacle. Now, what's the difference between the both of them? Well, nobody might actually ask you this in an interview question, but of course, if you're making use of this somewhere, maybe like in an organization, or if you need to work with Octopus themselves, because they are very massive in the US, if you need to work with them, they might actually ask you that. What is the difference between, or what are the two types of tentacles that we have? The first one is what? Listening tentacle. And then the other one is what? Polling tentacle. Now, what is the difference? Remember, this is the octopus server. These are the two tentacles. This is what? The listening tentacle. This is the polling tentacle. Now, the polling tentacle, it always listens for instructions. It will always listen on port 10, 9. I've even crammed the port 33 because I use it every time. It always listens on port 10933. Listening for what? The server always tell him to do something on this particular port itself. That is just what this guy does. Listening tentacle. He's just listening for instructions. He's staying, if you don't tell him to do anything, to not do anything. But it's when the server instructs it, Mr. Listening Tentacle, go and deploy this, and he does it. Why the other one? Polling, Polling, is always disturbing the server. Mr. Server, give me work. Mr. Server, give me work. I am ready to build. Give me work. So Octopus Deploy themselves, they recommended us to always make use of what? The listening tentacle. Right? It is recommended. But where is the use case for, or what is the use case for this polling tentacle? The use case is, for example, now if you have like a pool of servers that usually goes down, maybe because of cost, or if you're running in the cloud, and then you have maybe like several servers that are acting as tentacles. But of course, you need to always shut them down. Maybe if there's no workload on it, maybe in the night, weekends, to be able to save costs, right? If you always want to kind of like shut that down, then you should be able to create them as a polling tentacle, so that when they come back up, they will just go and knock on the server, on the Octopus server's door to say that, Mr. Server, I am now available. If it's dead, the server will know that, okay, because it has not gotten any request from the polling tentacle, then it is not up. So it's only when this guy is up, it will now go and knock. Mr. Server, I'm available. After 5 minutes, it will go back. I'm still available. I'm not dead. Mr. Server, you have not given me work today. That is what the polling tentacle does. Why the listening? The listening is always up, meaning whenever the server wants to deploy, it just goes ahead to deploy. Am I making sense? So this is usually the recommended way of deploying your agents, right? So let's now look at the Octopus Deploy itself. So this is our website. right? Of course, they're just telling you can see Teamcity is one of them. You can see why I told you that Teamcity is now becoming very, very popular. So Teamcity and Jenkins, these two. So they are saying that you can make use of what? Jenkins as your CI and make use of Octopus Deploy for what? Continuous delivery and continuous deployment. Teamcity as well. You can also, build from Argo CD because Argo CD works natively from BCS branches. So you don't even need to have any CI. Of course, that's what this icon is saying that feed in anything you want to feed me, and I'm going to deploy it. So that is what this guy is doing. So Octopus Deploy, you can see what it's doing. It is now releasing to what? AWS. It's releasing to Kubernetes, Azure, anywhere you want to release, Tomcat, and what have you. Do you understand? You can see the word they used. They use what? Continuous integration. Continuous deployment, because they are telling you that we are not only delivering, we're also deploying. So we are deploying to all of these targets. So you can see the deployment targets, right? So what else do we have? You can just go through the documentation. I would always recommend you guys to make use of Octopus Deploy. So let's see the pricing. So you can see the pricing formula. So they have a free version. So now you can run everything you want to run on cloud, on their cloud environment, meaning you don't want to install the server on your environment. You don't want to install the server on your environment. You want Octopus Deploy to be able to manage the server for you. That is where you will now make use of cloud. But it doesn't come free. You have to pay this per month, $10 per month, $12 for professional with all of this. And then the enterprise, has all of this. So, but for the server, Octopus on your infrastructure. So let's see what is there. So for the community version, you can make use of it for free. 5 deployment targets. We'll talk about this now. 5 projects, 5 users, multi-tenancy, and what have you. So if you should click on this start a trial, right, you can be able to run Octopus Deploy for free without any other, additional costs. So click on start a trial and let's see where it takes us to. So it should take you to a page. What is happening with my internet? Let us wait for it. So it would, I don't know what is wrong with my internet. Let me try it again. But you can open it on your end though. But it will take you to a page where it will ask you to download, the server itself. So this is going to be part of your assignment. You are going to download and configure the Octopus Deploy server. It's very, very easy and straightforward. But when you are, because I don't want to do that because I've already installed this for you guys. I installed this yesterday night, just for the sake of this practice. So I don't want to go through the installation again, but let me just log on to my Octopus Deploy server and then show you how it looks like.
What do you use in your environment, your own in your working environment?
I make use of Jenkins. I make use of Octopus Deploy. I make use of GitLab CI.
Okay, thank you.
Yeah, but primarily, most of my production, in fact, 85 to 90% of my production workload is running on Octopus Deploy. Okay. So I don't know why this guy is slowing down, but let me just log on to the server and show you what it looks like. So I've installed this. Of course, you have to download the Octopus Deploy file, although it's large though. But by the time you download it, you would double click on it. It's just a normal install, whatever. Because I've already installed it, right? You can just download it on your end and just install. Now, After this step, are you sure you want to cancel? Yes. After this step, right, it will now ask for something which is very, very important. It will ask for a database connection. So it's usually recommended that you should have a database installed. So if you cannot install a database, it's very, very straightforward. You can make use of you can make use of Microsoft's SQL Express. That is the community version for Microsoft. You can see it here. Okay, yeah, it's here already. I can also paste the link for you. Microsoft SQL Server 2019 is the free version. I think it was, you can see, it is reliable, free management system that delivers blah, 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 blah. So install this, very lightweight, install it. And please check on how to be able to install this. Install SQL Server on YouTube, very easy. There's a part where you need to specify your username and password. After installing it, during the installation of the Octopus Deploy, it's going to ask you for the username and password for your MS SQL, because all of the data will be saved within the MS SQL server. Very, very important. Right. So once you've done that, just click on next, finish. And you will now be able to specify any port that you want the application to run on. So after specifying the port, just go to your browser and start it. So this is my own Octopus Deploy. This was the port I specified, 4444. Your own can be anything. So let me log in. Okay, so this is how it looks like. Very simple, straightforward, nice UI, and what have you. So by the time you log in, you'll see some options here: dashboard, project, infrastructure, tenants, and all. We're not going to talk about everything here, but I'll just give you the basic understanding that you need. Then on Wednesday, on Thursday nights, we're going to have another class to finish this, because you can't finish CI/CD in a month, not even talk of one day, not even talk of 1 hour or 2 hours. So we're going to have another class this weekend, and this coming week for guys that are interested. It is not compulsory. We'll just have maybe like a late night sort of class, maybe 10 o'clock to 11 or 12 thereabouts, just to kind of like show you some other things about Octopus Deploy. But today we'll just talk about the basics. So by the time you log in, there's what we call space. So if you should click here on your topmost left-hand side, you see create spaces for your teams, blah, blah, blah. What does it do? Spaces allow teams to group their projects, infrastructure, tenants, library, assets, and what have you. So a space, in my own word, like in my own understanding, and this is what I also configured for my organization, is that I create a space and then I create a space per project. The same way I'm doing for Teamcity. Remember that for Teamcity, we are also creating a project for what? Per stack. So all my Golang projects, I'm creating them under a project on Teamcity. All my .NET projects, I'm creating them under project on Teamcity. The same thing applies to here. So you cannot say project on Teamcity is equals to space on Octopus Deploy. It's as simple as that. Do you understand? So you can create a space for your .NET project, for your Golang project, for your Java project, etc. Right? So that is just what a space does. So you can just go ahead and create a space. But for simplicity, I won't create a space. I'll just leave the default right now. So if you don't create any space, you are running within the default space that comes with Teamcity. So the next thing is what we call environment. Now, what is an environment? An environment is basically used to create different target names for your environment, or sorry, for your organization. I'll repeat. Is basically used to create different target names for your organization. What are targets? By the time you hear anything targets, just know that they're talking about what? Servers. They're talking about what? Your EC2 instance. They're talking about maybe there's a managed service on AWS or on Azure, that you want to maybe like deploy to. Whatever it is that you are deploying to is called a target. So environment is equals to what? Target names. So how do we create an environment? Just come to infrastructure, and on the left-hand side, you see environment, right? So let's create an environment. Add environment. So what environment do we want to do? Let's say we want to give it QA. Save it. That's all. That is all about environment. So you can also give it a description. Maybe this environment is basically for deploying to the QA or testers servers. It's as simple as that. Save it. That is just everything under environment. Now, how do we now install Tentacle? It's very simple. How do we install Tentacle? Tentacle, for you to be able to install a Tentacle, right, you need to always install it on your target. Remember, I said target is your what? Server. So if you have a server that is responsible for building your Docker images, right, you're going to install a Tentacle on it. If you have a server that is specifically for hosting your Docker images, you're going to install a Tentacle on it. If you have a server that is specifically for your .NET project, you're going to install a Tentacle on it. If you have a server specifically for maybe Java project, you're going to install a Tentacle on it. So all of those things are called deployment targets, which was what I said I was going to talk to you about here under their community. Under their, let me go back. You can see 5 deployment targets under the fruits here. Really, you don't even need more than 5, so to say, because most of the projects are going to be doing, of course, on a modern, software delivery lifecycle will always be, microservices and what have you. And about 85 to 90% of all of those workload are going to run as a container. So really, you can make use of maybe like 2 deployment targets to host your Docker containers. And if you're actually making use of Kubernetes, what you just need is just maybe like 1 deployment target, because of course that's what is going to be used to deploy to your Kubernetes cluster. So this is actually much more enough for your projects. Then of course we have 5 projects, 5 users. So you can have maybe like your entire DevOps guys, logging in to be able to administer Octopus Deploy, and we have all of this as well. Okay, so how do we now install Tentacle? So I think I have it open somewhere. Yeah. So under the documentation, again, you should always make the documentation your best friend. Very easy to understand and what have you. They're telling you Octopus Tentacle. You can run it as a service on Windows. You can run it on Linux. You can run it on any of the environments you need to install. So we need to. So now let us do something. Under these our projects, this our Golang build projects that we built last week that runs that builds an image and then sends to where now? That sends to the Docker Hub. Where's my Docker Hub? That sends to Docker Hub, right? Let us deploy that with Octopus Deploy. Do you understand? Remember that this CI has pushed to what? Docker registry here. We now need to inform Octopus Deploy that Mr. Octopus Deploy, pick this and deploy. So that's what we need to do. That is what we need to do. So we need to deploy to this server here. There's a server that I have here. We need to we need to inform it that it should deploy as a Docker container. So if I should do my Docker PS here, you can see nothing is running. I need to inform Octopus Deploy. Mr. Octopus Deploy, pick this image that has been built by the CI, pick this image and then deploy it on this server. So because I'm going to be deploying on this server, what do I need to do here? Anybody? What do I need to do here? What do I need to install here?
Tentacle.
Good. I need to install a tentacle here because it's that tentacle that is going to be responsible for running this particular image. It's as simple as that. So let's go ahead. So let's install a tentacle. Although I have already installed a tentacle here already, but I'm going to show you how to do it on a brand new server. So I'll make use of this, my Grafana server, my test Grafana server to be able to do that. So what is the process? Let's go back to the documentation. Documentation again, and click on Linux tentacle here. So what is it telling us? It's telling us the installing tentacle. You can either install it on what? Debian, Red Hat, and what have you. But because this server, let me even see this server. What's /etc OS we use? Okay, so this is the Red Hat server. So it means I'm going to be making use of what? The Red Hat repository here. Yes, so these are just the command I'm going to run to install the tentacle. So before I install the tentacle, you need to go back to your server and make it ready to accept that tentacle. So how do we do that? You click on your deployment targets, right? I have one already. Remember, I said I've installed one already, which of course we can make use of. So yeah. Okay, let's go back to our environment. I think I made, let me see what is missing here. Okay, I think when we're deploying, let me see if I can edit it. Let's see. Okay, it's fine. I actually wanted to create a tag for it. Let me see what I did here. Okay, let us go ahead. So let's prepare the tentacle. So let's add a deployment targets. So what deployment targets, like on what environment do we want to install the deployment targets? You can see the different options. It's on Windows. You can see listening and what? Polling tentacle. If it's on Linux, listening, polling tentacle, and then SSH connection. Okay, I didn't talk about the SSH connection. For the SSH connection, it's just telling you that you can also install a tentacle. And the only thing that will just be needed is just an SSH connection. But ideally, this is not usually recommended. What's usually recommended is to be able to make use of what? The listening tentacle. So this is also on Mac, there's Azure, there's AWS. You can make use of your ECS cluster, Kubernetes as well, and what have you. But the one we actually want to work on is what? Linux. So what do you want to install? A listening tentacle. So click on Add. Then the host name of the server, 10.3.4.9. By default, the port is what? 10933, just like I specified here. 10933. So that is what is going to be listening on. So, yeah, then connect to this deployment targets directly, what have you. So before I click on next, right, we'll now go back to the server.
Sorry, sir, I have a question.
Please go ahead.
There's in this where we have the proxy, where we have the connect to this deployment target through proxy.
Okay.
So how are we going to do that? Like,
This one is what I was trying to say here is, let me just use this board here. Remember, we are saying that from server to directly to the agents. But if you have a proxy in between, of course, you know the proxy have already blocked direct connection to the tentacle. So they are saying that if you have this kind of setup, just give us the IP address of this proxy and inform the proxy on how to be able to get to this agent, and you should be good. So if you have this kind of setup, then you need to provide it here. Connect this deployment target through a proxy. But we are not connected through a proxy, we're connecting directly. That's why I'm making use of this. Do you understand?
Oh, okay. Listen.
Okay, so let's go ahead to run the command. Oh. So read that. So I'll just copy the command and run. Okay, Tentacle is already installed here. You can see package Tentacle already installed the latest version. So what is the next thing we need to do? We need to there's a bash script that we need to run. Sorry, 1 minute. So when installing your Tentacle, right, you need to go to this directory. You can either run this bash script directly, or you go to this directory here. You can see all of the different configurations, you know, under the Octopus Tentacle folder. So what I'm now saying is that just run this bash scripts. So we're going to run this right now by just typing bash and then pass in that guy. So what is it not telling you? It's telling you that what is the name of the tentacle that you want to run. Of course, you can give it a name or you can leave a default. The default is what? Tentacle. So just press enter. If you need to leave the name, you know, if you need to leave the default name, you can just leave it like that. Then what is it saying? Say invalid, blah, blah, blah. The instance name will be tentacle. Good. What kind of tentacle would you like to configure? Listening or polling? Listening. Just type 1. Would you like the tentacle to store? Where would you like the tentacle to store the log file? Default, just press enter. Would you like the tentacle to install application to this? Default, press enter. Enter the port that this tentacle will be listening on. So this 10933 default, right? You can change it to any port at all that you want to, you know, expose the tentacle to be able to listen in on. But you cannot leave the default. I'll leave the default this way. Enter the thumbprint. Now this thumbprint is more like the API connectivity, or what authorize this particular server to connect to the Octopus server itself. That is what this thumbprint is doing. Now, where do you get these thumbprints? You get it here. So go back to your server. You can see the thumbprints here. So just copy this, right? And then paste it here. And it's telling you that you continue. So it would install the tentacle and start the tentacle. Right? So you can see that the tentacle has been installed. So once you get this message, tentacle instance called tentacle is now installed. If you named it Emmanuel, what you're going to see here is what? Tentacle instance Emmanuel is now installed. But because we chose the default, that is why you are seeing this. So what do we need to do? We now need to go back to our server and click on next. Right? So here, you just give it a name. Let's say this will be used to build our maybe IIS services, right? So what environment? Remember that we created the environments here. So what environments are we doing this to? QA, right? The target roles. Now, what is a target role? They are just tags. So basically, this was what I was looking for the other time. They are just tags to select the deployment target to execute a deployment or runbook against. Now, what this means is that you can have within this particular server that we just installed Tentacle on, right? This server can host your IIS applications. It can host Java. It can host maybe like Golang. Or if this particular server can only host IIS application, that is a tag. If it can host both IIS and Java, right? You will now have to specify the tag here. So let's say it can host IIS. So you add a new role like this. It can host Java as well. You add a new role this way, and you are good. So that by the time you now want to run it, you will now select the target roles. Do you understand? So I shouldn't even name this IIS service. I can name it IIS maybe and Java server, maybe server targets, just something descriptive, right? Then default machine policy, you can leave the default. This is the thumbprint. Then this is the URL. And you can also leave the default. That's to connect to the Tentacle directly and then save. So once you are done saving, right, click on connectivity here and check if it's healthy. Now there's what we call calamari, right? Now, calamari is what you have here, because that is what I usually used to identify. Let's go back to this our octopus. This small stuff that they are seeing here, right? That is what I usually use to identify as calamari. You can see that they are always under the tentacle. So all of these things here, they are called calamari. They are the ones that actually do the major work for the tentacle. Do you understand? So after you have installed an agent, the tentacle for the very first time, you need to upgrade the calamari. So that is what this is just telling you, and it's recommended. So just click on upgrade calamari, and it's going to run for a few minutes, and it will upgrade. Am I making sense?
Yes, sir.
Yes.
Good. So this has upgraded. So let's go back to our infrastructure, and let us refresh. So you can see that we have how many what? We have how many targets status? 2. And they're both healthy. How many listening tentacles do we have? 2, right? And these are the different roles. And they are supposed to be deployed to which environment? The dev and the QA environment. So lastly, 355. So lastly, let us quickly deploy an application. Let's deploy this Golang application. Let's deploy this Golang application using our Octopus Deploy. So how do we deploy the Golang application? So go back to your server and go back to your server and then click on libraries. So first and foremost, we need to connect to our GitHub repository. So how do you connect to the GitHub repository to be able to pull images? It's under library here. So you click on library, then click on external feeds. Under the external feeds, you add a field, just telling you that Octopus can consume packages from Teamcity, Azure, Docker registry, and all. So we need to connect our Docker registry as a feed. So click on add feed, right? So what kind of feed do we want? We need a GitHub repository feed. Sorry, a Docker container registry. Yeah. Then the feed name can be, it can be anything really. Let's give it maybe daas Docker reg. You can just leave it this way. Right. Then you can leave the URL by default, the part of the registry. You can also leave this by default, right? It's telling you that leave empty if the same as the URL host provided above. Meaning, if you are confident that this is the URL, right, you can just still leave it this way. Then you select your username and password. Sorry, this is not, is it GitHub? Docker container registry, yep. So what is my username? My username is my email.
I think you are using GitHub URL instead of docker.io URL. I don't know, I'm just saying.
So Docker container registry. Sorry, let me refresh this. I was also wondering as well, but let me refresh it and select Docker container registry. Yeah, exactly. So these are, thanks for the, because I was wondering that why was this thing not changing? So we can name this as read reg this way. So it has changed to index.docker.io. So for the registry part as well, you can just leave it empty if it's still the same thing as above. Then of course it is not anonymous. You need to supply username and password. And this is my, let me just check for my username and password, okay? Okay, Babula 05. Okay, 05 this way. My password. So let us save it and test. So it is telling me that for us to be able to test the connectivity to the Docker Hub, right, provide a package name. So this is an example of a package name. This daas_ima that we pushed last week. So let us go there and enter it here. So you can remove some spaces for us to be able to test. Then search. So you can see that it has finally connected because it's now able to pull the package ID information from Docker Hub. So we are good. We are good with this. Now, the next thing that we need to do is to now create a deployment project itself. Create a deployment project. So how do we create a project? Just click on projects, right? So click on add project. What is the project that we want to give this? Let's give it maybe Golang deployment demo. Right? You can also show advanced default group. You can just leave all of it this way. You can leave all of the defaults, then click on save. Then once you create this, the next thing is telling you that you need to create a process. Now, what is a process? A process is how do you want Octopus Deploy to deploy the application itself? That is just what a process does. That is just what, so once you're able to define your process, you are good to go. Now, because we will need to deploy that image, we need to pull that image and then deploy it automatically as a, to run within a Docker on our host where we installed the tentacle, right? We need to instruct Octopus Deploy to make use of the Docker process. It's as simple as that, which we are going to do here. So click on process, right? Then create process. So by default, it will give you all of the different pre-formatted processes that is used for deployment to any of the target environments. So if you need to deploy to Google Cloud, it's here. If you need to deploy to AWS, it's here. Azure, Docker, Kubernetes. You can see how simple and straightforward this is. So what are we deploying to? We are deploying to what? A Docker environment. So just click on Docker. Then scroll down. What do we need to, what do we want to do with the Docker itself? Do we want to create a Docker network? No. Do we want to stop a Docker resource? No. What we want to do is to what? Run a Docker container. So just click on add. So by the time you click on add, it is already telling you the different steps, all of what you need to populate. So the step name, run a Docker container, you can change it to whatever it is that you want to change it to. Now, we now need to select the rows. Remember that we created rows the other time. So let's just select the rows. So let's say, for example, now we want to, based on the first one I created, right? We want to run our Golang app, right? You can just select the Golang. Now, this is going to make use of the tentacle that has this particular role stored itself. So what is the next thing that we need to do? We need to specify our Docker feed. Remember that we created our Docker feed here, right? So specify it, the daas feed reg. After you do that, the package ID is just your image name. That's all. So what do we need to do? You can, I think you can just type, the name there. So I'm just being lazy. Let me just go and copy it again. So that's Emmanuel. So you can see it's even bringing out all of my images on my repository. So I want to select this, right? So what is the next thing we need to do? Connect a container to the network, default, none, bridge, host, container, and custom. So always select the bridge, because the bridge is what is going to help you to connect from the external ports to the internal ports. Now, this is what it means. On the target server itself, if you should do Docker network ls, see what is going to happen. Can you see bridge? Let me see. Can you see the bridge here? So bridge is always the default that will help you to be able to connect from your container outside to outside your host itself, so that you are able to call the application from outside of this host. That is why we need to select a bridge driver. You can see a couple of networks that are also making use of bridge as well. So that is what we need to select here, bridge. Then the port mapping. Port mapping is the external port to the internal port. So let's add a port mapping. So I know that when we started, when we built that image, the port that we exposed within our Docker Lite was what? Port 8080. So that is usually the container ports, 8080. Why the host port can actually be anything. Let's choose port 3333, just for sample's sake. Then once that is done, you can leave the remaining default host entry bind mount. If you have a bind mount, of course you can always add the volume binding here, meaning on your server, if you need all of the data from the container, right, to be persistent, meaning you want to create another folder on the host, so that even if the container goes down, because by default Docker containers they're ephemeral, meaning once they go down, all of the data is lost. So if you need to persist that data, all of the data that is being collected from the container, you need to persist it to pass it to the host container. For example, now if you create a folder here, mkdir, and I name it my volume, you can pass this my volume inside, just the same way we did here. Just the same way we did here. You can see. Just the same way we did here. But this is not this is not a bind mount. Do you understand? This is a volume binding. Of course, you can just check the differences. The differences between what we have, like the difference between volume binding and bind mounts, right? So this is just similar to what we did here. So if you need to persist this as well, if you need to persist all of the data from this conf to persist it outside on the host here, and you need Octopus Deploy to be able to do that for you, you'd have to do that here by, adding the volume binding and some other things. Okay, we start policy, meaning if the container should go down, what should happen, right? You can select the restart policy here, maybe on failure, always on stop. You can also play around with this. Then this is also the command instruction, meaning if you should type your Docker run, do you want to run like some form of a specialized command as well to accompany the Docker container instance that you want to run. For example, you can do a Docker run just the same way we have like this, right? The same way we have like this, and then maybe you want to specify something else. Maybe you should run build, or you should run something else. This is called a CMD. So this is what you're going to specify here, right? The command. And of course, environment, run condition. You cannot leave all of these defaults. So what do we need to do? You will save this. So let us save the process. So this is the process that we saved. This is just the instruction of how the tentacle and the calamaris, how they should run this as a Docker container. It's as simple as that. What is the next thing we need to do? We need to create a release, which is here. So by the time you click on create a release, it will tell you that this is the version of the release. This is the package at what version 507. You will notice that when I was specifying this, I didn't choose the image tag. By default, this is going to choose the latest tag, which you can see here, 50-7. And that is what you can see here as well, right? 50-7. So it will always deploy the latest for you. So it's saying that this is the version, this is the package, release notes. Release notes, you can just enter the release notes here. Enter the summary of what has changed in the release. Remember when I was discussing about the change management here? Remember when I was discussing about the change management here, this file here. So whatever it is that has changed, everything that has changed here, right, that made the developer to work on this is what is going to be within the release notes here. Enter the summary of what has changed in this release, such as which features were added, which bugs were fixed. These notes will be shown on the release page. You can edit this later, blah, blah, blah. Then click on save. So what do we now need to do? We now need to what? Deploy to dev. You would also realize that the only thing I selected was just what? The role. So by default, the role is now going to go and look for the environment for where that role can run on. So that was why it chose dev. I didn't choose IIS and Java because that one is for QA environments. I only chose Golang because I had created a role that every Golang application to be able to run on dev. So that's why you can see dev here. So if you should look up here again, you can see that deploy to dev. So click on deploy to dev. And of course, it's giving you all of the information, environment. I want to deploy to dev, when, now, steps, failure mode, and what have you. And it's telling you that the tentacle that you want to use is healthy and is ready. That's why you can see this green icon here. So deploy, and let us see it perform the magic. So click on task log here, and it might take a little while, maybe like 1 minute or 2. You can see that it is trying to acquire the packages. The same way Teamcity always check out the code. Octopus Deploy is also acquiring the packages. So acquiring packages is that, see, it has connected to that our Docker feed, and it has downloaded the image onto itself. After downloading, it is now following all of the processes that we've defined to install. So you can see that this is now successful. It is telling you that what? Congratulations, you have successfully completed your first deployment. You have a minute, blah, blah, blah. Close it. Now let us now go to see if truly, remember that when we run Docker PS, nothing was there. So let us now see if this would give us anything. So you can see the ports that we defined. You can see the image and the container ID. So let us now check if this application is ready to accept connection. So what do we need to do? The IP address of this server and the port 3333 here. So the IP address of that server is 10.3.4.24:3333. So let's see. Can you see? So our app is fine. So you can see the magic behind CI/CD. So what it's going to do is just to define what it needs to do. Remember that the CI as well, we have defined everything we need the CI. The CI is pushing to the repository here, right? And we have now instructed the CD to be able to pick that and deploy to the target environment. Now, the last thing for this class, which we're not going to do today, is now to complete the CI/CD, so that by the time I make a commit, remember where we are coming from here. By the time the developer makes a commit here, it is expected that Teamcity should what? Build it, create an artifact. Octopus Deploy should be able to pick that latest artifact and deploy. So the next class, which is going to be on either Wednesday or Thursdays, we're going to make a commit, right? And we'll just wait for like few minutes or few seconds. By the time we make this commit, it is expected that once we go and check on production, everything should be fine. Everything would have been deployed. Do you guys understand? So that brings us to the end of today's class. I don't know if anybody asks any question. Stop
Yes,
share.
sir.
So yeah, please go ahead.
Please, sometimes they always say the best practice is for us to get a file that we can reuse. Like in some cases, like you want to deploy to Kubernetes and you're using Jenkins, there's a file on your GitHub that you write and you can reuse it again, or someone else can reuse it. And secondly, can you use Terraform with Octopus? With Teamcity and Octopus?
Yes, of course you can. So we've not talked about Terraform yet, but you can also do that as well. So instead of informing Docker to go and do the deployment, Octopus would inform Terraform that, please, this is my TF state. These are my TF files, right? Make use of that. Connect to that one is more advanced. Connect to AWS and run this, so that if I make a commit, right, it's expected that Teamcity would pick it up, right? Send the artifact information to Octopus Deploy. Octopus Deploy would inform Terraform to do the actual deployment. But if I don't need to provision a new environment, because you can always use Terraform if you want to provision an environment and then run the application. If I don't need to provision an environment, I don't need to make use of Terraform. I can make use of Ansible. To do that as well, to just go and deploy. But of course, why do you need Ansible when Octopus Deploy can do the job for you? Do you understand? So those are just the use cases. Any other question?
Okay. my own question is about last class in conjunction with this class. So when you are running your agent, right, for that native Golang application, so you
Yeah.
make use of the server IP, which is 10 dots and so on, right? So
Yep.
now, what if you want to use your local system IP, maybe your system IP? I think it's
Of
not
course.
working with. It was
Of course,
unable
you
to
can.
work.
You can. So what you just need to do is install install TeamCity agent natively. After you do that, right, then if you need to use that server to be able to build whatever application that you want to build, of course, you need to install the language stack on that server. So for example, now, if you want to make use of that server to build a Node Express application, you need to install Node.js and pass the environmental variable so that from anywhere within the server, if you should cat the path variables, that is cat space dollar paths, capital PATH.
Yeah.
You should be able to see all of the environmental variables there, right? So that by the time you now install an agent on the server natively, TeamCity should be able to run maybe the node command on that particular server easily without any issues. Remember that the agents is just a command line. You are just informing TeamCity to run this on your server itself. Do you understand?
Yes, I get that part, but I think my own problem is because I was trying to run it natively. My own problem is when I use my system IP, the agent was throwing error, retrieving IP, unable to connect to my system IP. So I'm just trying to see.
Okay. Yeah. Yes. I understand. What the issue is. So in that scenario, right? What is the basis of or what is giving you the IP address that you're actually making use of?
So
how will you get the local IP address?
So I use 3 IP. I use my system IP using IP config ETA address, the command to get my system IP. I tried that, it did not work. I tried using 127.0.0.1, which is with the port 811 and so on. It did not work. And I tried localhost too. Localhost and port.
None of it will work. Connect to a Wi-Fi.
Okay.
Connect to a Wi-Fi and then get the IP address of that Wi-Fi and try it.
Okay. Yeah, I'll do that.
Yeah, try it. Let's see.
Okay.
All right.
I'll drop the update on the
okay,
chat.
No problem.
Thank you.
Any other question? All right, Riz, yes, please go ahead.
Actually, it's regarding the error that we got, that we got, which me and Olawale we posted on the group, which you actually gave us some help with regarding the need to remove the last volume.
Yep.
When we removed the volume and did the installation of the agents, we met with the error whereby the agent is not, I don't know which word now. Like after installing the agent, right? We need to check and see if the agent is not compatible, which normally after installing the agent with that particular code, and then we authorize it is to be compatible, because it's expected that with that installation, we should have our Docker installed in the Docker image. But we didn't really succeed with that. So I don't know.
By you building within your build steps, are you sure you're actually making use of the Docker build and all of those commands within your Docker build steps?
The Docker build, yes.
Okay, you're very, very sure that I'm making use of that, because if you're making use of the Docker build steps, right, then you should be able to detect that that of course you have Docker installed within the container, unless on the host box you're actually making use of, right? Do you have Docker installed on the host box?
I'm using my local host. I have Docker installed there.
Okay, you have Docker installed there on your
Yes.
local host.
Yes.
Okay, good. Now, this is what we'll do. How is Docker running on your environment? Are you making use of Docker desktop?
Yes.
Good. Don't make use of Docker desktop. Do you
Okay.
have a free account on Azure or AWS? Like, I need you to do it from a native Linux box. Install Docker on that environment and then run your agents on that environment. You are not going to have that issue.
Okay. So can I use maybe Oracle VirtualBox?
Oracle VirtualBox. Yes, you can try that. You can try that. But to clear all doubt, I would just advise you that maybe you should just run it on cloud. You can run it on AWS EC2 instance. You can just quickly like spin a server or on Azure. Don't run it on Docker desktop for now. Do you understand?
Thank you.
Because when I was actually doing this, I think I also had issues with Docker desktop. Docker desktop is not usually friendly with things like this. Do you understand? So that was why I just used a server. So all the servers you are seeing, they are all on my cloud environments. Do you understand? So
Thank
let's
you
see.
very much. Thank you.
All right. Yep, guys. So I think that will be all. So question is, are we ready for the presentation tonight?
Please, before you move on, please, trying to sorry guys, I was trying to do the go over the Teamcity project on my own, but I don't know, there are a lot of errors that I can't start talking about here, but this one particular one that I'm facing now, where you're about to build where you have to create build features and then add build, then Docker support. By the time I try to add the registry connection, I can't find the Docker registry there. I don't know why. Though the connection I did, it was the test connection was successful, but when I wanted to add the
Docker support, right?
feature, yeah, the Docker support, I can't find it. I don't know why. Though the Docker support, from what I read here, as in the registry connection, it says Teamcity will sign to your Docker registry before.
Can you see my screen?
Okay, let me go to. Yeah, I can see what's going on. Yeah.
I'm talking about this part here.
Exactly, yeah.
So you are saying that you can't find this?
No, I can find that Docker support, and then when you click the add registry, that's where.
So don't click here now. Docker registry.
Yeah, it's not showing the Docker registry.
Okay. You need to create you need to go to administration.
Okay.
Then click on authentication. Then where is this thing again? 1 minute. Sorry. Projects. One minute. Sync. Okay, it's here. So on the project name, hello, Bamde.
Yes, I'm with you.
So
Project
click
name.
on the project itself, not on the build, on the project, right? Then
Okay.
edit the project, right? Then
Yeah.
on the left-hand side, you see connections,
Connections.
then add connection. So you have to first add this Docker registry. Do you see?
Yeah, I can see. I think I did this now. Then this, if you click here now, it will ask for your username and password. Then you put the
Yes.
authentication.
Yep.
Yeah, I did that.
Can you see?
I tested it. It was successful. Yes.
Okay. So
This
once
was
you do this, you will now go to the build. Remember, this is for project. You now go to the build this way.
okay.
So under the project, you can see this is a project. You now click on the build this way, and then edit configuration. So you will now click on build features.
Build features.
And then add a build feature. So that is where you will now select what is it called now? You select the Docker support.
Yeah.
Sorry, where is it again?
Build features.
Okay, it won't do this thing again because I've already added Docker support here.
Okay.
Yeah, but you would just select Docker support this way.
Maybe I should try the connection all over again.
Wait, let me even delete this so that I will show you.
I have the I can share my screen. Maybe you should see. I have the connection already. So
Okay, share your screen. Let's see.
okay. Okay, go. So here it is. This is the. Can you see my screen?
Yes. Okay. So this is your project. Good. So you've added the Docker registry. So click on projects.
Yeah.
Up. Okay. So collapse that. So click on this. Edit configuration. Build features. Add build feature. Then select Docker support. Then add registry connection. Okay.
This is it.
Okay. No connection provided. Let's see. Cancel this. No, click on the add feature. Docker support. Save it. Okay. Then edit it. Edit the Docker support. Okay. Yeah. Click on add registry connection again. Okay. So something is wrong somewhere. Cancel it. Go back to your root project. Okay. Edit projects. Okay. Connections on the left-hand side.
Should I delete this?
Delete it. Okay. Add another connection. So Docker registry. So under the display name, change that thing to something else. Yeah.
Oh, okay.
Can just change it to something descriptive.
Okay.
Without space though. Yes. So enter your password.
This password is the like the PAT kind of. So yes. Okay, you can see it now. So,
Okay. Yep. So go back to the. Edit
okay,
it.
so since we have this one here, let me just
Yeah, I can edit it. Something is wrong somewhere. Something is wrong, maybe with your configuration. Just a minute. But anybody experiencing this? Do you have anybody? Do you have any other person experiencing this issue?
I don't know. Maybe in the guy, I don't know. Nobody has complained about this though. Or is there anything? Does it have anything to do with authentication?
This stuff that you have running, where is the server? Where is the build server? Where is it running on?
On my Docker desktop.
Okay, Docker desktop. That Docker desktop,
Yes, it gets. I mean,
I would have just advised maybe you should just instead of making use of Docker desktop, maybe you can make use of the other guy. Just pin up a server on maybe AWS or on Azure, and let's try it. I'm sure you're not going to have this kind of issue.
okay.
But for Docker desktop, I'm not sure of the functionality, because I'm sure that it's not usually compatible with some of these our things, some of these CI/CD tools, so to say. It's just for just build an image and let me just check. It's just for minimal things, so to say.
Okay.
Yeah.
No
Let us try
problem.
that.
Yeah. All right. Thank you. Appreciate it.
Okay. All right. So it appears that some of us are still, having some issues with the assignment itself. So let's make use of cloud instances, right? Let us make use of cloud instances and see where that takes us. I'm sure I'm not going to have all of these issues with Docker desktop and all. So what do you suggest? Should we move the presentation to next week? Does mean that we're going to have an extended time for both presentation and a period to finish this. So should we move the presentation to next week Friday, so that we just know that we're not going to have assignments for this, because I already have assignments for this, the CD parts. So what do you suggest? Any suggestions?
Maybe there are people that are done with their work.
What did you say?
Yeah.
I say maybe there are people that are done with their
work they can present. So that will be out of it then. The other guys can now come up with yours.
Yes, I don't want to have two presentation sessions.
Okay.
Yes, I just want to have
same
one.
assignment.
Let's just move it to next week then.
Okay. So we should move it to next week. Then what will now happen to this assignment? It means we're going to have pile up of assignments. So do we want to do that? Are we good with that? Or I should reduce the assignments?
No, we're good with it. These assignments can also come along the line. I don't know.
Yes,
Okay.
you can also drop this assignment so that we can have it.
But you need to finish because the what is it called now? The Octopus Deploy is
A
much
continuation of the
more
first one.
exactly. So you will need to deploy the Octopus Deploy. Oh. I need you guys to actually lay your hands on that Octopus Deploy because that is where the real work is. That's where the real work is. So you can see that right now, like we're having so many assignments and what have you. So I will do that and I will put it on our GitHub account so that you can start working on it. But please, we need to finish this before Friday. Before Friday next week for the presentation. Then on either Wednesday or Thursday, we're going to finish this CICD class so that we can go to Terraform on Saturday next week. And after Terraform, we'll talk about monitoring. After monitoring, we'll go to AWS. After AWS, we'll go to Azure. So, all right. I think that's from share. Do you have any concerns? Hello, Ada. I've not heard your voice today. Congratulations on your certification.
Good evening, sir.
Good evening.
I'm here, absorbing everything.
Absorbing, okay. Congrats. So,
Yeah.
how are we watching this one now?
Watching. I'm still an upcoming artist.
Congrats. Okay. All right. Any other thing? What about Fumi?
She took an excuse.
She's unavoidably absent.
Yes.
Okay.
Our baby is not. Our baby is sick.
Oh, okay. Try and check up on her, please. Guys should try and check up on her to find out how she's doing. No. All right, Sean. Any other thing? No, okay. Sean is on the call. Hello, Sean.